I'm Dr. Coble. I teach a junior class in nuclear plant modeling and controls, and the research that my team does applies data analytic techniques to nuclear power applications. So we take the data that are already being collected at nuclear power plants and fuel cycle facilities and apply statistical analysis and modeling techniques to understand what's happening with the equipment, the processes, and the systems so that we can make decisions about how to operate and maintain our facilities that will keep our very high safety and security standards while reducing the cost of putting nuclear power on the grid. A lot of the work that my team does is really computer-based, so there's a lot of code development, a lot of statistical analysis, data exploration, and data visualization. And we are always looking for students who are interested in learning more about code, about algorithms and techniques, and how to apply these tools across a variety of problems, including equipment monitoring, process monitoring, cybersecurity, kind of across the board in the instrumentation and controls of nuclear power facilities.
So hello, I'm Jason Hayward, Associate Head of the Department and Lead for the Graduate Program in Senior Design. My research involves radiation instrumentation, especially for non-proliferation and imaging, including work from materials to components to systems and algorithms. My group maintains a size of 20, with $1.5 million a year in research, and does some work for different parts of the Department of Energy, Homeland Security, Defense, as well as Oak Ridge National Lab, Y12, and other industry. We do work with some undergraduate students too. We also maintain office and lab space at Oak Ridge National Lab and Y12. We are now opening a new accelerated research center next summer in our new building. The research is multidisciplinary in nature, so we also work with professors and students in electrical engineering, computer science, and material science engineering departments. Other courses I teach include radiation biology, and a graduate course that includes labs at Oak Ridge National Lab on the topics of research, detection, imaging, and non-destructive assay of nuclear materials. More info about my group is available at radideas.utk.edu. Welcome.
Hello, my name is Ivan Maldonado. I'm a professor of nuclear engineering at the University of Tennessee, Knoxville. I have been in the industry for approximately 25 years, and there are three key areas that I think are of most interest to me to work with students. One of them is the development of nuclear fuel management optimization and the associated methodologies for light water reactors and other fuel cycle applications. I also enjoy working with students on the modeling and simulation and analysis of next generation reactors, including advanced nuclear reactor fuel concepts, small modular reactors, generation 4 concepts such as the molten salt reactor, and most recently fusion reactor systems. We employ a lot of these techniques to do computational isotopic management and accounting of reactors, a very important activity for commercial and experimental facilities. I have worked with approximately 20 PhD students and about 40 master's students over my time as a professor. And if you would like to work with me or are interested in that area, let me know. Thank you.
Hello and welcome to our incoming nuclear engineering freshmen. I'm Professor Heilbronn. I'm sorry I won't have a chance to meet you in person like we normally do, but at the very least I'll meet you in a couple of years when you take NE 233 Introduction to Radiological Engineering, which is taken typically during the spring semester of your sophomore year. I enjoy working with undergraduates with research projects. I do typically radiological engineering focused research projects such as protecting astronauts and electronics from the radiation environment in space. And I also do some medical isotope production research that's for isotopes that are used for cancer therapy. I encourage you to take a look at any of our 4 student societies that we have in the department. I'm the faculty advisor for the Health Physics Society. So if you're interested, please look me up. I look forward to seeing you all soon. Go Vols.
Hi, I'm Nick Brown, and I'm a faculty member at the University of Tennessee, Knoxville in the Nuclear Engineering Department. My group focuses on nuclear reactor and nuclear fuel safety, and we're always looking for excited and hardworking students to help us do interesting work. We focus on nuclear energy, which is the largest low-carbon source of electricity in the United States, comprising roughly 20% of our electricity. Right now we have 99 operating power reactors in the US, and most of those power reactors were built about 40 years ago, so they're getting ready to retire. What my group does is try to find ways to make the existing nuclear fleet safer, and then also, as we replace these nuclear reactors when they retire, to make the next generation of nuclear reactors even better, and to expand the missions of nuclear energy beyond electricity.
Hello, everyone. Welcome in the department. My name is Maik Lang. I'm an associate professor in the department, and my research group focuses on the behavior of materials under extreme conditions. We look to nuclear fuels and nuclear waste forms. We mostly look to radiation effects, so we bombard them by different types of radiation and then study how the material degrades. But we're also interested in the general behavior of nuclear materials under extreme environments, so we include also pressure experiments where we squeeze on the materials or expose them to very high temperatures and compare the different extremes and see how the material perform and try to improve the performance. And to understand the atomic scale damage that is produced in the materials, we use very advanced characterization techniques, which is provided by large user facilities, such as the spallation neutron source at the Oak Ridge National Laboratory, where we use neutrons, or we use X-rays at different synchrotron sources, for example, the Advanced Photon Source in Chicago. And I have several undergrads doing research in my group, and I can only highly recommend, if you're interested in doing research, that will be a unique experience if you work with graduate students and the professor together. I can only highly recommend that. So welcome again.
Hello, I am Brian Wirth, University of Tennessee and Oak Ridge National Lab Governor's Chair Professor of Computational Nuclear Engineering, and I would like to add my welcome to all of you to the University of Tennessee College of Engineering, and in particular the Department of Nuclear Engineering. Our research is focused on understanding and predicting how nuclear fuels and structural materials perform in complex nuclear reactor environments. One example is shown here on the left with the Boeing of zirconium alloy fuel assembly. Our research group is focused on utilizing computational materials modeling as well as some experimental characterization to understand and predict the dynamic evolution of materials behavior, which can be quite extreme. In addition to that fuel assembly, we see some examples of fuel cracking here and the formation of a surface morphological feature in tungsten due to low energy helium implantation. So our research is really focused on both predicting the safe operating lifetime as well as utilizing that knowledge to devise new materials that will improve the economics of future nuclear fission and nuclear fusion power plants. We do employ a few undergraduate researchers in our group, so if you're interested, please feel free to send me an email, bdwirth@utk.edu, and I welcome you to Rocky Top and go Vols.
Hello, my name is Eric Lukosi, an associate professor in the Nuclear Engineering Department. Undergraduate students will most likely meet me in their sophomore year when they take NE 250, which covers computational methods and tools that students will need to be successful in their junior and senior level courses. I also teach a junior level course, NE 401, which covers radiation detection systems in a laboratory environment and how to analyze that data. My research group works on the development and application of various radiation detection systems that spans application spaces from nuclear security to high energy physics and medical physics. One of our most important projects right now is the development of the highest spatial resolution, highest neutron detection efficiency imaging system ever developed that we hope to install at the spallation neutron source. I'm very excited to have our undergraduate class joining us in this very challenging time, and I look forward to meeting each and every one of you.
Hi, I'm Professor David Donovan, and my specialty area is in the area of plasma physics and fusion technology. So a lot of our work is based in the area of how we're trying to eventually create a nuclear fusion power plant that could put power in the grid. We really specialize in a particular area of the fusion device that's really near the wall, an area called the boundary plasma, and a topic that's called plasma material interactions, which is where the plasma hits the wall. So we look a lot about how do walls degrade and how do they survive the intense heat flux of a fusion reactor. So I have multiple graduate students that work with me in my group, and we've actually had quite a few undergraduates that have worked in various projects in my group as well. I teach several graduate courses, as well as NE200, which is the first class you'll take in our department as a sophomore, as well. And I also teach the NE460 course, which is a senior tech elective course, which is Introduction to Fusion Technology. I'm happy to always be able to chat with anybody. I've always encouraged people to, whenever they're curious about research, to reach out to faculty and ask us what we do, and talk to our grad students. It's a great way to learn about the specialties in our department. So I look forward to seeing everyone on campus real soon. Thanks.
Hello, my name is Ondrej Chvala. I'm Research Assistant Professor in the department. I teach NE362, Numerical Methods and Fortran class, and I run Study Abroad program, NE427, Experimental Reactor Physics Laboratory, where we go to Prague in Czech Republic, right here, and we play with the reactor for a week. We also visit International Agency for Atomic Energy in nearby Vienna, Austria, and learn about nuclear material safeguards and global aspects of nuclear energy. I teach graduate level classes ESE 511 and 512, Introduction to Energy Sciences and Technology for the Bredesen Center. I run local nuclear engineering computational cluster, and my research interest is focused on molten salt reactors, the next generation nuclear technology, specifically their core neutronics, fuel cycles, dynamics of the entire power plant system, and safeguards of this system. But I'm also interested in advanced light water reactors such as NuScale. Welcome to the department.
Hi, I'm Dr. Richard Wood. Oh, sorry. I teach Nuclear Engineering 400, which is senior seminar. I also teach a number of graduate classes. I wanted to welcome you to the University of Tennessee and take this opportunity to give you a little information about some of the research that I conduct. I lead research on instrumentation and control technology for nuclear power plants. I have a research team of 6 graduate students and 1 undergraduate student. The topical areas in which we conduct our research are autonomous control for reactor operation, advanced and space reactor INC systems, INC modernization at terrestrial nuclear power plants, and regulatory research into key issues. Basically, my research deals with what's effectively the nervous system of a nuclear power plant. For space nuclear applications, autonomous operation is especially important. If you're interested in these technologies or potential for research, I invite you to boldly go to my office during your undergraduate career, and we can talk about the opportunities that might arise.
Hi, everybody, and welcome to the University of Tennessee. I'm Vladimir Sobes, and I'm a new assistant professor in the Nuclear Engineering Department. I currently teach 2 graduate courses where you will learn the mathematical methods behind computational simulations of nuclear reactors and other nuclear systems. I am, however, on the undergraduate committee for the department, so I am looking forward to interacting with you in that role. In terms of research, as a new faculty member, I'm building a new reactor physics research group where we will be studying a wide range of topics ranging from fundamental nuclear physics to artificial intelligence algorithms, which will autonomously design nuclear systems from scratch. We currently have 6 undergraduate researchers working in our group, so the opportunities for engaging student research are plentiful. And if you're interested in doing undergraduate research, I highly encourage you to reach out to myself or speak with any of the students in our group. Thanks, and see you around during the fall semester.
Hi, I'm Steve Zinkle, and I teach 3 undergraduate and graduate classes on various aspects of nuclear materials for fission and fusion energy applications. My group research is involved in materials for extreme environments. Includes both current and next generation fission reactors. This includes things for both applications here on Earth as well as space applications. We're currently involved in some research to enable crewed missions to Mars. And also we have a lot of activities with development of fusion energy. If you understand the fusion energy, it uses seawater as the fuel. So sometimes we have to take trips to test out the fuel for future fusion reactors. Also involved in advanced manufacturing and fundamentals of radiation effects. We use a lot of unique facilities like the ion beam facility, the UT campus, as well as some characterization facilities available at Oak Ridge National Lab. So I hope you all are enjoying your orientation, and welcome to UT. Thank you. Bye.